Morning folks, welcome to my first demo for Sapphire 24. We're going to be talking a bit about SAP EAM, in particular Asset Performance Management, which is the up and coming new advanced solutions that SAP offer to extend the value of SAP products. Just before we go there, I'd like to do a quick intro about Delaware. So Delaware is a particular area of focus, really looking to extend our capabilities in enterprise asset management, which is why we're focusing on asset performance management. But in general, we're a partner that really is passionate about driving operational improvements and efficiency out of companies. We're a global company with some 5,000 professionals, and we're one of 11 platinum partners in a global sense. We operate a 24/7 capability across the globe and can deliver for our customers in a global context. Just to give a little bit of focus around where asset performance management actually takes part. Really, it's about exploiting the opportunity around asset criticality and driving improvement around asset performance using APM as the primary tool. But as you can see, APM is only one aspect of the life cycle that SAP EAM can support, and is the focus of this session. But I'm more than happy to talk about any other aspects. If you come down to stand 320 today, that'd be brilliant. In terms of asset performance management, the sort of value that it can deliver on top of standard SAP products, it's really about improving the visibility of your assets condition, giving you the ability to drive down things like downtime. Safety and compliance are always a key area of opportunity and for any company a real focus, along with things like reduced costs, along with optimized strategies around maintenance and performance. One of the key areas is around obviously improving decision support for key engineering and maintenance staff. Just to summarize, mitigate risk across your asset base, reduce downtime, increase maintenance productivity, and improve asset tracking and monitoring. And all of these features and functions are something that Delaware have developed into what we call our FAST templates, in particular, in this case, FAST EAM, where we've developed the capability to deploy these solutions in a really rapid and focused way. Just to summarize the intent of what I'm going to try and show today, a quick view of the data synchronization that takes place between the core SAP S4 environment and APM in the cloud. Talk a bit about how you actually maintain and manage the asset criticality templates and information, and then perform the assessments that really about driving the opportunity to improve performance. Ultimately then, how do you then align that with strategies and maintenance and operations? So as I said before, it's a particular script I'm going to run through, and really before I dive into the product itself, just a quick view of a typical SAP Fiori Launchpad. All of the functions and features that support asset performance management are maintained in this view. There's various ways of accessing the various functions and features, either through the Launchpad itself or through other functions across the top bar. So I'm just quickly going to give you a quick idea of the synchronization that takes place between SAP S4 HANA and the APM cloud product. As you can see here, what we've identified is essentially the S4 HANA instance that we're integrating to, and the client in particular that we're going to harness the data from. But more than that, beyond that, we've got to actually describe the objects that we're looking to integrate with. As you can see here, we're really targeting two primary objects from a master data point of view. There's functional location and equipment records. Now, if you're familiar with plant maintenance, you understand that those represent the technical objects that represent the asset base. Other things we've identified lower down in this view are the plants themselves, where those assets reside from an organizational point of view. This is the basis for the integration, and is pretty fundamental to the proper operation of APM. Just looking at the integration monitor now, what you can actually see in front of you is all of the information that's been passed between SAP S4 HANA and the APM relating to the equipment and functional location records. So it's all of the attribution that resides in each of those data objects is passed up to the APM solution for further use. This is configurable, but in this case, we're taking pretty much most of the field records that reside in the equipment and functional location. And you can see this was last synchronized on June the 4th. Okay, just taking a view back from the primary launch pad, I'm just going to take a little bit of a tour through the technical objects themselves. So going back to what I just said, this is the information that's been passed from SAP S4 into APM and represents the same asset records between S4 and APM. It's total synchronization between the two systems with the same data records. And each of those lines represents an equipment or a function location. As always with SAP, I can filter this pretty extensively by object type. In this case, I'll filter it by equipment. So these are all the specific equipment records that we have harnessed from SAP S4 and brought it onto APM. And I can drill down into these equipment records and look at a lot more detailed information. As you can see, information covers the structural information, general data, manufacturing information, location data, responsibilities, account assignment, etc., etc. Again, if you're familiar with SB plant maintenance, all this information will be very, very familiar with you. Other elements that come up with the record are all the characteristics and classification elements that have been maintained for every equipment record or function location. Similarly, all the indicators. So this is measurement points that you have maintained for each equipment record, again, will be translated and brought up as part of the integration. A fundamental element of APM is really establishing as an organization your risk and criticality template. So this is how you perceive risk associated with all your equipment and how you then manage that risk and criticality as part of your strategy. As you can see, we've maintained one criticality template. A lot of companies will have more than one variant of these, but again, this is the sort of thing that we would work very closely with the operational engineering organization to define how you see the criticality and risk of your assets across the whole asset base. And you can have as many of these templates as you need. In this case, this is a demo system, we've just maintained the one template. The first thing you're really looking to define are what we call impacts. So these are the impact of the asset having downtime or an incident, has a cost impact, has a safety impact, has a risk impact, or an environmental impact. So again, these are entirely configurable for your business. In this case, we've maintained 4 different impacts. I'll just select one of the impacts and show you a little bit more detail of what's behind that. And there's 2 particular dimensions that are of interest here. The first is the financial impact of that impact actually taking place. And the second part is the occurrence or frequency of that impact. So when you're defining a risk matrix, it's the impact of something happening, and how frequent that thing will happen defines the risk that you're going to have associated with it. The second part to this is essentially the threshold. So if it does happen, what is the numerical value you're going to attribute to this, so that you can assess what you then do with that information from a quantitative or an objective point of view. As you can see, the first overall threshold decides what sort of reaction I'm going to have from a maintenance strategy point of view. Am I going to run to fail if this happens at this level, or am I going to run a failure mode and effects analysis or an RCM analysis? And that's the cumulative, which is made up of all the thresholds which I'm now looking at. So the health and safety threshold, production threshold, cost thresholds all contribute to an overall assessment. So having established my company's template, or however many templates I've got, they then utilize that to manage your assessment. So based on that structure, against all your critical equipment, you apply a rigorous assessment. What I'm actually going to do here is I've got a couple of assessments, one that has, as you can see, been created but is in process, which means I can show you some variations of how that will react to different values. And then I've got a couple of assessments here that have been released, actually in process. So I'll quickly run through the impact of playing around with the numbers. As you can see with this assessment, I've assigned equipment for it. So literally what I'm doing now is for that specific equipment, I'm going to make a judgment about the health and safety implications, the cost implications, etc. You can see at the moment, the area that I'm highlighting has an assessment and a value of 2.2. 2.2 from a risk and criticality point of view is very low. So in this particular case, it's not a critical equipment, so run to fail. So if something happens or you detect a problem with it, it's not that important to me, so I'll just let it run to fail. So what I'm going to do now is play around with some of these numbers, and you'll see it going back to a different type of strategy. So a couple of changes I've just changed in health and safety. I'm going to change in the production impact. Again, high criticality, high frequency. Fingers crossed. If I save this, you should probably see this go to a FMEA type strategy. Brilliant. Okay, the demo worked well. So, you can imagine you would go through all of the assets in your business that are of really importance to you, and you apply this sort of rigorous assessment. Ultimately, it gives you a lot more visibility around the criticality of your assets and how you react to that from a maintenance strategy point of view. And that's the direction we're going with this product. Next thing is to actually manage the assessment and apply the reaction to an FMEA type analysis. So that's lovely. I've done the assessment and it's recommending a particular approach. What does that actually mean in terms of work that I'm going to perform against that asset to drive a behavior of improvement performance? Again, I've got a couple of versions here. Given the time we've got, I'll look at the release version, which is an in-flight recommendation. As you can see now, we've actually split the asset into 4 primary areas. For this pump, there's a number of different areas from a reliability point of view that you need to pay attention to. This drives the behavior in terms of work that you will carry out. So in this case, the bearing, the impeller, the lubrication, and the mechanical seals are areas that you really want to focus your attention on in terms of follow-on work. You can see the sort of failure that you would expect to have at a bearing level and how you're going to apply work to prevent that failure from happening. Having managed the assessment, the next step in the process is to basically manage the recommendations. As you can see, there's various types of reactions. You either have a reactive recommendation or you have proactive. Proactive is tending towards performing maintenance in a planned way, and behind that would be things like maintenance plan, item, etc. So I'll select one of these in particular for demo. As you can see, we've now identified the sort of failure modes that can potentially happen within the asset. So bearing failure, shaft, impeller support, etc. Again, this dictates the sort of logic we're looking to apply when it comes to converting this into maintenance action. The technical object in this case has been assigned, is identified. In this case, it's the pump. We understand the risk profile associated with this. Again, we've done an FMEA assessment against this particular asset. You can also see some other features at the top of the screen which identifies the sort of financial risk that's associated with failure. And the last part in the process that I'm going to show you today is, okay, we've done all this assessment, we've reviewed it, we've structured a way we wanted to react to the assessment. Now you want to implement it. This is converting it into a physical maintenance plan to execute the work. As you can see here also, there's a couple of different ways we can react to this. And the top line is a proactive process. So this is us planning to do something. The second line is reactive. So something's failed and you're immediately driving a behavior. Again, with all these things, that the information for the asset, for the maintenance, flows through all the different phases of the project. So, and one of the points I made right at the start is the visibility of information, visibility of performance, condition, reaction from a maintenance point of view, is throughout the whole process. Again, same information coming through from failure. And the last part, which is essentially stringing all this information together, we have the assignment, which is the asset itself. In this case, it's a pump. We've identified what we're going to do to prevent failure, in this case, a 6-month oil change, directed towards lubrication failure. And the last part in the equation is the maintenance item, maintenance plan, and the tasks that are in behind that to execute the maintenance. So when this is executed, this recommendation, it becomes a genuine maintenance plan within plant maintenance through the integration, and the work will be executed in line with the schedule, hopefully preventing any further failure of that particular asset. So just to summarize, you can imagine how if you assess all of your assets that are critical to you in this way, using this technology, you can drive a behavior improvement across your asset base in a really, really significant way. You have the information in plant maintenance and S4. It's about exploiting that to the next level. Thank you very much, everyone, for listening to me. Any questions from the audience? Thank you very much.